Okay, I welcome you to our next topic, which is going to be work, power, and energy. So we shall start by tackling work. And you know, work, we have seen this before, right from our O level. Now we again looking at it. And generally, when you talk about work, in your mind, you should have two things: the force being applied on any object, and the distance it covers. So we should also know that the work done depends on the force applied on an object and the distance that object covers. This force is always directed. This object always moves through a distance, and that distance moves in the direction of the force. Where the force is being applied, the direction the force takes is where the object moves. So we shall define work as the product of force and distance moved in the direction of the force. Down here in our first figure, you see a force is being applied, a force F on the first diagram. Then what will happen is that that force is being applied in a horizontal direction. As it moves through a distance S, as it is being applied, it covers a distance S. So you find that that object, which is maybe a block or anything like a car, moves through a distance S because a force F is being applied on it. Then when we come to the formula, we shall derive the formula from the definition. So force is going to be, work done is going to be force applied and the multiplication of the distance moved. And this distance is moved always in the direction of that force. What about if the force applied on that object is not horizontal nor vertical, but it's an inclined force, it's an oblique force. In other words, it's being applied at an angle theta above the horizontal. Then that means that force, like in this second diagram, that force has two components, a horizontal component and a vertical component. But since this body has weight, it means the vertical component may not have a big effect, but the horizontal component is going to make this body to move. So we shall just resolve this force F horizontally such that it becomes F cos theta. So F cos theta is a horizontal component of force F, which makes it to move in a horizontal direction. Then if we have that horizontal component of force, then we can get our work done as that horizontal component of the force times the distance that the body moves. So we shall say that work done is F cos theta times S. Then mathematically, if we arrange, the trigonometrical function comes afterwards. So it becomes F times distance S cos theta. Of course, everyone should be knowing this, that force, the unit is joules. Joules, or you can take it as Newton meter. Newton, because the force being applied is in newtons, then meter is the distance covered is in meters. F in newtons and the S in meters, so Newton meter. Then force is a scalar quantity. So being a scalar quantity, that means we should majorly be looking at joules, because Newton meters sometimes you may use it for moment. So in order not to confuse joules with joules for work with moment, let us stick on joules for work done. It is better. Yeah. Then I think I can come back for the next session and we look at this situation whereby, is it easier to pull a table or to push it? What is easier? What do you think? As you can be thinking about it, when you have a table in your dining room and you want to extend it somewhere, is it easier for you to pull it or to push it? Let us come back and look at that.